Hey everyone, this is Greg from ChemCore. In this video, we're going to be going through the hydrocarbons worksheet. Before getting started on this worksheet, let's just define a couple terms that's definitely going to be asked later on the video. Now, what you'll also notice is that I like to combine some topics from earlier videos or earlier units that I feel that you guys should not be forgetting. And so what I like to do is with new videos, from time to time in my worksheet, I'll have a requirement or a question that will need some kind of introspection and maybe some information that you've learned from the past. And so this is a perfect example from it. In part C of the question we're going to be doing, they're asking us, well, I'm asking you guys to identify the number of sigma and pi bonds. And now, to be clear, I'm kind of looking for carbon-carbon, sigma and pi bonds. But if you guys don't remember, we talked about sigma and pi bonds in the last unit, in unit 1. If you guys have a feeling like you forgot that, or you just, what you want to review it, head back to unit 1, and there's a whole video on it. There's also a video on orbital hybridization and atomic structure, anything if you feel like you're lacking on those fields. Now, the main part of the question is going to ask us to draw a bond line, which hopefully you guys at this point have no problem doing, and also to identify the molecules alkane, alkene, alkyne, or cyclic. And then further than that, if it's a cyclic, alkane, cyclic alkene, or cyclic alkyne. And so let's remind ourselves that a really easy way to tell that it's an alkane is carbon-carbon single bonds, only carbon-carbon single bonds. Now, easy way to tell if you have an alkene is carbon-carbon double bond. An easy way to tell if you have an alkyne is you have a carbon-carbon triple bond. And so when we have a cyclic hydrocarbon, well, kind of in the name, it becomes a cycle, or we can call it a ring, right? It becomes a ring. And so once we're going through these problems, we're kind of going to have some problems where we'll definitely see some cyclic molecules. So definitely the first part is converting to a bond line. And so remember, we only care about our carbons, not our hydrogens. And so the first structure, let's make my pen a little thicker. We have, let me redo that. We have 1, 2, 3, 4, 5 carbons in this straight chain. And we have 1 carbon coming off right over here. And so we can definitely classify this as an alkane. I only see carbon-carbon single bonds. And if you were to count them up, we would have 5 sigma bonds and 0 pi bonds. Now the next structure, I see kind of this ring over here, and so little hexagon. So I'll go ahead and draw that out first. I do see a double bond on this side, and I also see a carbon coming off from the left side, and 2 carbons coming off the top with a double bond at the end. And so what we can definitely talk about this is it's an alkene. It definitely has an alkene functional group, right? And it is also cyclic. And more specifically, it is a cyclic alkene. So we can classify that as well. And if you were to count it up, you would get 9 sigma bonds and 2 pi bonds. Now in the next problem, I see this really complicated looking ring. Now, apologies that I wasn't able to draw kind of these carbon, hydrogen, these Lewis structures very cleanly. It's kind of hard to generate structures like this. But if you were to count it up, you would get kind of like an octagon. And so my best rendition at that would be something like this. These aren't too easy to draw, but this is my best shot at doing so. Looks not bad. The thick pen makes it hard to see the carbons, but I hope at this point it's pretty easy to see. I do see a ring, so we can definitely call it a cyclic hydrocarbon. And I do not see any double bonds, and I don't see any triple bonds, and so we can call it kind of a cyclic alkane. Cyclic alkane. And you should be able to get 10 sigma bonds and 0 pi bonds. Now the next problem, we have these 1, 2, 3, 4, 5, 6 carbons in a nice straight chain and a double bond on the 3rd carbon. And so this is definitely a straight chain, so it's not cyclic, but we do have a double bond. And so we can classify this molecule as an alkene. And you should be able to get 5 sigma bonds and 1 pi bond. In the next problem, I do see a ring, kind of a hexagon. So let's go ahead and draw that. And now, kind of unique structure, I tried to do my best, is we have a triple bond off to the side over here. And so it looks something like that, as well as 2 carbons branching off the ends. And so we can definitely call this a cyclic hydrocarbon, but we can also classify it as a cyclic alkyne, right? Because we do have that triple bond. And now, in the video, I mentioned that cyclic alkynes kind of struggle to exist, but they do begin with cyclopentine, right? So 5 carbons. This does have 6 carbons, so it's more like a cyclohexo. The problem is that no matter what, there's a reason we draw these triple bonds straight, and the fact that this ring forces it to be bent is not very good for the stability. This is kind of a sneak peek into something in the future that we're going to speak about. But there's a very big reason why these cyclic alkynes do not like to exist. And you should be able to get 8 sigma bonds and 2 pi bonds. And this next structure is kind of easy. We have these 3 carbons in a line, and then 1 carbon branching off. This is very clearly an alkane with 3 sigma bonds and 0 pi bonds. The next problem is also not too difficult. We have these 4 carbons in a very straight chain form. Nothing else going on, which means we do have an alkane. And you should be able to get 4 sigma bonds and 0 pi bonds. The next problem, I do see a little ring in the center. And so let's go ahead and draw that hexagon. So 2 double bonds off to the side, 1 carbon branching off the top, and 1 carbon branching off the bottom. And so this is definitely a cyclic hydrocarbon, and we kind of can classify it as an alkene. Now I do hesitate to call this alkenes. I will for now, but technically alkenes only have 1 double bond. Alkynes only have 1 triple bond. This is something we call a diene. But for now, we will classify these as alkenes. I think most courses will not hold you accountable for understanding, the difference between alkenes and maybe multiple double bonds. But you should be able to get 8 sigma bonds and 2 pi bonds. The next structure, a little bit going on, but as long as we follow along, we shouldn't get into any trouble. I do see a carbon kind of here at the center with 2 carbons branching off. And then a carbon over here, triple bonded. And so let's draw that triple bond. We have a carbon at this end that is triple bonded, connected to another carbon that branches up and also branches to the side. And so this is classified as an alkyne. We do have a triple bond over here. And so 7 sigma bonds and 2 pi bonds. The next structure, I do see 4 carbons and then 1 carbon kind of branching off up. And so we could classify this as an alkane with 4 sigma bonds and 0 pi bonds. The next structure, I kind of see this little pentagon twisted, but I mean, we don't have to try to draw it twisted. We can just draw it like this, a regular pentagon. And then 2 carbons branching off the top, as well as 1 carbon branching off the side. And I do see a double bond somewhere in this ring right over here. And so we could classify this as a cyclic, definitely cyclic hydrocarbon. And since I do see that double bond, it is a cyclic alkene, meaning that we have 8 sigma bonds and 1 pi bond. The next structure is kind of similar to one of the structures I had above. We have a carbon here with branching up and down, connected to a triple bonded carbon. So that's that triple bond. And then we have that triple bonded carbon connected to one of these carbons that is double bonded to the end carbon. And now, interestingly enough, we have a triple bond and a double bond. And now, what I said is that as soon as we have a triple bond, doesn't matter if we have a double bond in it, we do classify this molecule as an alkyne. Although we could kind of have some properties that would belong to an alkene as well. And so we do have 6 sigma bonds and 3 pi bonds. The next structure, I see this end carbon that is triple bonded. So you have this triple bond to this middle carbon, and then 2 carbons branching off up and down. And so I do see this triple bond, so it definitely is an alkyne. And it has 4 sigma bonds and 2 pi bonds. Last structure on this page has these 4 carbons super straight, and then 1 carbon branching down. And this is an alkane with 5 sigma bonds. Now the next structure, kind of funny, it's just a square. And so if you watch my video, you should be able to classify this as cyclobutane. But it does have a double bond, so it's actually cyclobutene. So we can call this a cyclic alkene, meaning that we do have 4 sigma bonds and 1 pi bond. The next structure, we got a lot going on, so let's slowly follow along from the top. We have these 2 carbons connected like so, and then a double bond following down, a carbon coming off to the left, and then 1 carbon coming off here. We have a carbon and then a double bond, something like that, and then a carbon branching down to the right, a double bond, and 1 more carbon branching down. And so we definitely could classify this as an alkene, which has 9 sigma bonds and 3 pi bonds. The next structure also got a lot going on, but it's okay, we'll handle it. We got these carbons from the left that is connected to a triple bond, and that's connected to another carbon which branches off to the right, and then down, and then another triple bond off to the end. And this, we can classify this as an alkyne. You know, if I go back, I really should draw this double bond kind of straight. So let's draw this double bond straight, a triple bond straight. And so we do have 8 sigma bonds and 4 pi bonds. The next structure, we do have this ring, cyclopentene, with this double bond over here, and then a carbon branching off, meaning that we do have a cyclic alkene that has 6 sigma bonds and 1 pi bond. The last 2 structures, we have the straight chain of 1, 2, 3, 4, 5 carbons. We have a double bond off here and then a branch, meaning that we do have an alkene with 5 sigma bonds and 1 pi bond. In the final example, we do have this ring with 6 carbons, a triple bond to the right, and then 2 carbons branching off. So we could classify this as an alkyne with 8 sigma bonds and 2 pi bonds. The last 3 questions are really just definition questions, and we actually defined these before we even began the worksheet. The first question is asking us to explain the definition of an alkane. Now, an alkane is a hydrocarbon that contains only carbon-carbon single bonds, or sigma bonds. The next one is asking us to explain the definition of an alkene. And so an alkene is a hydrocarbon that contains at least 1 carbon-carbon double bond. And the final one is asking us to explain the definition of an alkyne. So an alkyne is a hydrocarbon that contains at least 1 carbon-carbon triple bond. That concludes the worksheet working with hydrocarbons. If you're not familiar with these concepts, make sure to go back and watch the topic video, and I'll see you guys in the next one.